Hello everyone, welcome to the course of Microwave and Optical Communications. In today's class, we are going to learn about optical sources. Okay, so before getting into the topic of optical sources, we need to have an introduction to the previous topic called as light sources, which we are talked about this particular LED as well as laser. Okay, so let's once again brush up what is this particular LED as well as laser. Okay, now coming to the light spreading with respect to LED, okay. So LED, as we have already discussed, it's an coherent light, okay. So the spreading of the LED light will be like an widespread and also will be like a spectrum, okay. So this particular LED is suitable for the multimode fibers, and due to the incoherent light, the light rays are broadened, okay, and are very much widespread, okay, into various direction. Coming to the laser diode is highly directional, okay. So compared to the LED, the spreading of the laser diode light is very less, okay, and it is an coherent light, okay. So it is best suitable for the single mode fibers. We have already seen the comparisons of these two in the previous topic called light sources. You can go through the topic as well. And coming to the data rate, if at all you're transmitting the data using an LED, okay, you can transmit a less than 200 MB per second. And coming to the laser diode, it is somewhat more efficient manner in order to have an optical fiber communication. So more than 2 GB per second can be transmitted using a laser diode, okay. And coming to the applications, LED kind of transmission of data can be seen in the low data transmission like LAN cables and all those things. And coming to the laser diode, the high speed long optical fiber communications will be used with the help of these particular laser diodes, okay. And coming to the optical sources, so it's a simple block diagram where you will be having an electrical transmitter, a light source, which may contain an LED or a laser, and this particular light source is connected to a light detector using an optical fiber cable, and this light detector or photo detector is again connected to an electrical receiver, okay. Now, what are these light sources means, or the light detectors we are going to see? See, in an optical communication system, there exists an optical transmitter as well as optical receiver, as we have seen here, right? This one. This is a transmitting unit and this is the receiving unit, okay. Now, the optical fiber acts as a medium between optical transmitter and optical receiver. So, as we have already discussed, there is an optical fiber cable which acts as a medium between this particular transmitter as well as receiver, okay. So, beside that, at the transmitting end, you will find a light source through which we emit the light, electrical energy, whatever the electric pulses transmitted by this electrical transmitter, that will be converted into light with the form of electrical to optical converter, where light source are mainly used for that. And once the data is integrated or the electrical signal is integrated into light, it will be sent to the through the optical fiber cable and it reaches the light detector, okay. Now, let's see what is this particular light detector. See. So the light sources converts electrical signal into optical signal. We have already seen. Now the point is light detector or the photo detector. These detectors are mainly used at the receiving end, where the light signal or the optical signal is converted into electrical signal again. Okay. So here, in order to transmit through signal through optical fiber cable, using a light source, we are converting the electrical pulse into light energy. And once the light energy is transmitted through an optical fiber cable, again using a light detector or a photo detector, we are converting that light into electrical energy again. Now the electrical receiver receives that particular electrical pulse, which was firstly transmitted by the transmitting end. Okay. So this is how the particular mechanism works. Okay. So how these optical sources behave. Okay. So when a conduction band electrons recombine with the valence band holes in the forward bias, there will be an energy difference, which is considered as the energy band gap. Okay. So this particular band gap produces photons. Okay. Photons, you already know, right? Okay. So this particular energy of photon is calculated. Photons are nothing but it's a kind of light energy. Okay. So this particular energy of photon is calculated by Eg. Okay. So Eg is equal to hc by lambda, where h is the plane constant of the wave, c is the speed of light in the vacuum. Okay. And lambda, we all know, lambda is considered as the wavelength. Okay. So the value of the wavelength with respect to light is given at 1.24 by Eg. Okay. So here are the units of lambda as well as Eg with respect to micrometer as well as electron volt. Okay. So these are some of the calculations with respect to the optical sources.